Hello students, in discussion of test number 96 onwards. Okay, here the questions which are repeated frequently, I have not discussed those concepts. Why? Because several times in these mock tests from 1 to 95 we have covered them repeatedly, sometimes 2 times or 3 times. Okay, so I am discussing the questions which are generally not covered or any new reaction which is also given in the other books. That is the target of this selective discussion. So first question is, which acid yields maximum? Which acid will yield maximum alkyl bromide in Hunsdiecker reaction? ठीक है? Which reaction? Hunsdiecker reaction. In the revision also this reaction is covered. In the revision, quick revision videos you can see, or in the notes, this reaction Hunsdiecker is mentioned along with the mechanism. So here in the last test also, mock test discussion, that reaction was covered. So here the key point is, we know that in Hunsdiecker reaction, what we prepare from carboxylic acid, we prepare alkyl bromide or alkyl chloride with one less carbon. Like here 1, 2, 3, 4 carbons. So what we will get? We will get 1, 2, 3 and here Br. Right? Same way all are carboxylic. So remember one thing, the information that in the mechanism, primary is fastest or primary yield is maximum, then secondary and then tertiary. Although it is free radicals are formed, that is why we are getting R radical combining with Br. But here the information given that here yield observation is primary maximum, then secondary, then tertiary. So same information you have to use, that here it is primary, it is secondary, it is tertiary, it is also just like secondary, although primary is only this one. So go for answer which is A, which is also given in the good reference book about this order, not given with the proper reasoning. So only observation is mentioned, that is primary, then secondary and least for tertiary. Next question is compound A. We have to find the compound A. On oxidation with osmium tetraoxide, you have done this reaction in notes, which is syn hydroxylation. In alkene topic you have covered, you can check your notes. Followed by reaction with HiO4. This reaction also covered in the carbonyl compounds. Oxidation using periodic acid gives hexane 1,6-diol. You can think about this question and then you can answer it. I am explaining it that here 1,6-diol means 1, 2, 3, 4, 5, 6, and here CHO, there CHO. It is finally formed. So think about that among these options, which will give this product hexane 1,6-diol. Now osmium tetraoxide. Osmium tetraoxide is a syn hydroxylation, right? And then in this reaction triple bond is there. We know that with triple bond osmium tetraoxide no such reaction is given. With 6 cyclohexene, if it is forming, that reacting with it, syn hydroxylation takes place and it will give OH. Syn hydroxylation stereo is there, both same side. I am not using that stereo part because not required in this question. Then here after this HiO4 bond will be cleaved. Here one OH gives aldehyde, there also one OH gives aldehyde. In this case bond cleave ketone and aldehyde, eliminate that option. Here also after the reaction OH and HiO4 is oxidation of alpha dihydroxy compound or alpha beta dihydroxy or vicinal diol. So it will be finally giving ketone both carbon atoms. So among them only answer is B. Then third one is ketone NH2OH in acidic medium. pH range, if you remember, hydroxylamine, a particular pH range is there around 3 to 5. You have done this in the carbonyl compounds reaction. So after this oxime is formed. What is the oxime formation here? It forms C double bond NOH. Okay, that is the reaction first from the carbonyl compounds. Next is sodium in ethanol. In which chapter you have done this reaction? Sodium in ethanol. In the amines topic you have done that in the reduction of amines or in the formation of amines from nitro group, from different functional groups. So there we have used sodium in ethanol, which is generally termed as ball blank reduction. Okay, generally. So here after the formation of oxime, it reduces the oxime C double bond N due to reduction by sodium in ethanol. It is electronic reduction and it gives pH CH, here CH3 and then NH2, right? So here you can revise amines where multiple reagents we have used for this reduction, for reduction to amine formation. Last question is, among them, which of the following compound will be least reactive with H2O? Now you can see that in this case they all are the acid derivatives. That means which reaction it is? Nucleophilic acyl substitution, right? So we know in the order is acid halide fastest, then anhydride, then amides, sorry, acid halide, anhydride, ester, and then last is amide. Why? Because if you remember, the plus charge here is maximum in case of halogens. Why? Because we know one thing is that they are having minus I effect dominating, first thing. Other point is that their leaving group tendency is more, whereas in amide NH2 leaving tendency is less. So in short, that point if you remember, amide will be slowest in the reaction with the H2O, which is nucleophile or hydrolysis reaction, very slow with the amides. Now here we eliminate option 1 and option 4. Now between C and B, here pH means benzene will further delocalize electron and plus will be even reduced, right? And whereas in CH3CONH2, NH2 part is common, that has to be substituted. So in short, between B and C, C will be still more faster in reaction because here pi electron will shift here, plus on the carbon will be reduced. Then if it is less positive here, nucleophilic attack will be slow. Nucleophile is H2O. Therefore, among them, the best answer is B. B should be correct one, right? Okay. Next question is fifth. This is the substrate given, that CHO group, CH2, this one, and OH. H plus or OH minus is given, and then a product is mentioned. Is mentioned in the question, but you can try it if you want to try, and you have to identify which type of reaction it is. As by going through the options, I have not given the option, I have not given the product form. Think about it. Next is, which of the following forms a yellow oil with NaNO2HCl, and these are the three options written. I am solving question number 5. Think about it, pause the video if you want. Now here alcohol is present and aldehyde. Remember, you have done one reaction. Remember quickly, think about it. It is the nucleophilic addition reaction or nucleophilic addition of alcohol on carbonyl group in presence of dry HCl. Similar reaction, only that here H plus or OH minus both mentioned, but we know with dry HCl it is given, so we can use that reaction. That here that becomes OH plus because of the acidic medium or dry HCl, and then internal nucleophile will attack here. 1, 2, 3, 4, 5, 6, a 6-membered ring with O included in it, and this oxygen will combine with the carbon where it is having OH and H. Finally, I am forming this. So this carbonyl compound is with OH and OR. It is hemiacetal formation, right? So if you are not able to recall it, you can revise the notes or in the videos. It is covered addition of alcohol to carbonyl compound. So it is which reaction? It is inter or intramolecular? It is intramolecular hemiacetal formation. Next is, which of the following? I hope that you have till now you have been cleared with that part. It is yellow oily substance with NaNO2HCl and all are amines. Now recall, we have done this test with HNO2, that is nitrous acid, or NaNO2HCl. Primary amines give N2 gas. Secondary amines give yellow oily substance. In the POC also it is covered. Mainly in amines topic, at the end of this test we have done in the amines topic, you can see. So secondary amines give yellow oily substance, which is due to the formation of N-nitrosamine. You can see that reaction, so I am not writing any reaction. Directly using the information, yellow oily substance due to secondary amine. So first is secondary amine, yes, PH, NH, methyl. Second one also secondary amine, third one also secondary amine. It means all the three are correct, A, B and C. Okay, next question, think about it also. Which best among these concepts, which is best explaining that orthonitrophenol is more volatile than para-nitrophenol? A, resonance, B, hyperconjugation, C, hydrogen bonding, and D, steric hindrance. Think about it. Eighth is Carius method, already given there. If organic compound mass is 0.099 grams and it gave 0.287 grams of AgCl precipitate, find the percentage of Cl. So try these two questions. I am answering question number 6. So in question number 6, it is very basic example of NCERT only, that orthonitrophenol is more volatile than para-nitrophenol because of Because of intramolecular H bonding in orthonitrophenol that makes it steam volatile, and that's why we use steam distillation method to separate them. So here among these options, this is the H bonding means intramolecular H bonding. ठीक है, then 8th question is percentage. You can use logically, बिल्कुल simple question है. That is, you can use a basic mole concept part, that percentage of Cl will be what? It is equal to whatever is the mass of Cl. How we find? You have mass of AgCl. In AgCl, find out its moles, 0.287 upon molar mass of AgCl, which will be 108 plus 35.5, 143.5. ठीक है, that are the moles of AgCl. Now whatever are the moles of AgCl, which will also be the moles of Cl, because it contains only one Cl. So these are the moles of Cl also. If you have moles of Cl, can you find mass of Cl? Yes. Multiply its moles with its atomic mass or molar mass, 35.5. This complete part is the mass of Cl. Again, listen if you want. We have done this part previously in the quantitative analysis video separately. And then divide by the mass of the organic compound, which is 0.099 into 100. That is the way you can solve this question. Mass of the AgCl divided by molar mass of AgCl will give moles of AgCl. This will also be moles of Cl. And then multiply these moles of Cl into the molar mass of Cl. It will give you mass of the chlorine present. Divide by mass of organic compound into 100. Question number 9. Here you can see alkyl bromide. ठीक है, NaIHO. That is the way it is written in the question in the NTA app. You have to identify the products formed, because when you go through the options, you will get option where possibilities are there. So think about it. Although this particular type of example, if you have gone through the video of comparison of SN1, SN2, E1, E2, there this example is covered, or in the table general brief comparison I have done initially, there you can see this example type is covered. So you can, if you have gone through that one, you can relate that example. Question number 10th, KB order. Although it is simple question, but why I have considered it? Because explanation given is wrong. That's why I have taken this here. Otherwise, you people all, I think you will solve it correctly. Only part is the reason given is wrong. Question number 11th, which carbonyl compound among them undergoes racemization reaction in presence of H+, that is acid catalyzed or base catalyzed medium? Here also the explanation given is wrong, but answer is correct. So think about these three questions. I am answering question number 9th. Now here the key point is, firstly it is tertiary. ठीक है, with NaI minus, that is Na plus I minus water acetone. Acetone is taken so that the alkyl bromide becomes soluble more. Key point is I minus. Now recall in the SN comparison video, it is covered, it is given in the crucial concepts playlist. You can see in playlist, in the crucial concept playlist, it is mentioned. So in that last column, I have mentioned that tertiary no SN2. Tertiary with strong nucleophiles like I minus, SH minus. These are strong nucleophiles, but they are weak bases. With them also SN1 mechanism. That point you can use here directly. And when it is which reaction? SN1. That means a carbocation is formed, and this carbon is chiral. You can see ethyl, methyl, propyl. I minus attacks from both sides. So you will get both the products. Like if I write in terms of Fischer, I here, there ethyl, there methyl, and there propyl. Plus backside attack is also possible, ethyl, Me there, Pr there. I am using that one, otherwise in the options you can easily find out they have given carbon, carbon here. So the point is from the reaction mechanism. Question number 10th is KB order. Now order is on the basis of lone pair delocalization. We can easily answer that here this is sp3 nitrogen, nitrogen not in delocalization, D is maximum. Here nitrogen lone pair delocalization in 3 rings, that's why it is least. Here nitrogen lone pair 2 rings, it is better as compared to C, and here in 1 ring. So after D, A is more basic, then B, and then C. Reason is not given there. which is not given correctly, so you can use the lone pair delocalization. Aliphatic we know more. Among aromatic you can only use lone pair delocalization, not primary, secondary or tertiary aromatic amine. Question number 11. In question number 11 you can observe racemization where firstly it is which reaction, it is normal tautomerism. ठीक है, it is simply tautomerism, and you have done this mechanism that in acid catalyzed or base catalyzed, in short alpha hydrogen participates, alpha hydrogen there also, this side also, this will not result into any racemic. Here also, here alpha is there but it will not result into any racemic formation, racemization will not take place. I think I have written, okay, here both are different, yes. So in this case you have to find where you will get racemization, means where alpha carbon becomes new center is formed, which is chiral, new center. So you will use not reason given there, which is given addition of HCN will result into racemic. Incorrect. Why? Because addition of HCN will result into all chiral carbons, and that will be finally it will be a racemic mixture. So all four will be correct by that reason. That's why I'm saying you can use the concept of tautomerism. Like in the first one, if you write the structure, it will form like this, OH there, this one. Now you know stable form is which one? Keto form. It will again undergo tautomerism and you will get back double bond here, H again. Okay, this center remains achiral. But in this case, when the same thing happens in B, I hope you are getting it. If you are not getting, then revise the tautomerism. If you form enolate like this will be double bond here, ethyl and methyl. Now in this case, when it undergoes quickly racemization, means it is undergoing dynamic equilibrium. Now this carbon, which is now sp2, it will gain minus charge. When minus comes, then H plus can attack from both sides. That is why you will get here double bond, there Et, methyl, and this is a new chiral center formed. Although it is still chiral center, but here H can attack from both sides. Why? Because this carbon, due to tautomerism, double bond comes, and here initially chiral center, double bond comes, means it becomes planar. Then again dynamic equilibrium leads to the double bond O keto form and minus charge on carbon, then H plus can attack from both sides. So this is a newly generated chiral center here. This undergoes racemization. Same way here, if you try, right side no chiral center, no hydrogen available, left side available, but it will not result into any chiral center. Same way there, no such kind of thing. So reason is incorrect, but answer given is correct in that question. Then next question, which gives nitric acid with NaNO2 H2SO4. Okay, now in this question, if you observe that this test or this is reaction which is covered in the previous mock test also, which is relative from the or which is related to the Victor-Mayer test. Victor-Mayer test we take for the alcohol. In between we convert that alcohol to nitroalkane, and then this is a reaction proceeding. So here you can use direct information that nitric acid is formed by primary nitroalkanes. Going from the primary alcohol, it forms after treatment with AgNO2, it forms nitroalkane, then same trend of the reaction giving red color. So in short, using the information of Victor-Mayer test, you can see it is which degree amine, it is which degree nitroalkane, it is secondary, this is tertiary, it is primary. After this reaction, here HR present plus HONO generated. Okay, so here you can take it like this, HONO, like this you can take this and these all leaving it, and you will get this type of NO2 there as it is, and there NOH. In short, you can see Victor-Mayer test for all, for primary, secondary and tertiary. Alcohol or nitroalkane, you will get the final products. For each we are getting different product. Here this is nitric acid formation, and then in alkaline medium it gives red color formation also. Okay. Next question, you think about this question, I'm reading it. A compound A with this formula C9H8O5 on methylation with CH3 twice SO4 in alkaline medium NaOH forms methyl derivative. ठीक है? Then molar mass of the compound formed after the reaction is given, that is 210. Find number of hydroxyl groups present in A. So here this question is little bit information based, although you can solve it by simple mole topic or simple logically you can find the answer. But the here important point is that one new reagent it is mentioned, methylation, and where it is used. Generally we do not use in the generally we use this in the phenols to anisole. Like phenol, if you take treating it with the dimethyl sulfate in NaOH, then phenoxide ion formed and then substitution takes place, it gives anisole. Okay, so here that is the information for you, maybe that this is that reaction where phenols undergo formation of anisole, that means from OH to OCH3. Now here how many oxygens are there? 5. We do not know how many phenols are there and what is the structure. We are not bothered about that. Why? Because simply by doing the subtraction we can find, and division will give you the answer. How? Final reaction of A with the methylating reagent will give you a compound which has molecular weight 210. Okay? What is the molecular weight of this compound? When you find it, you will get it is 196. Right? So total mass of the compound after reaction is 210. Initial mass is 196. We know in the initial compound when methylation is done, then in place of OH after the reaction, whatever number of phenols are there, whatever number, we will get methylation here and it forms OCH3. Here 5 oxygen are there, we do not know how many are phenolic OH, maybe ester groups are there or alcoholic groups are there, we do not know about that. So simply we use the total mass of the final product after methylation is 210, initial compound has mass 196. When you do the subtraction you will get the difference of 14. Okay? That means the methylation is done and CH3 group is adding, and only this is the difference coming in the final molecular weight. Now we check if one OH is undergoing the reaction, it forms OCH3. That means one H is reduced and how many atoms are increased? CH3, means 12 plus 3, 15 added, and one H is lost from there. So finally you will get difference of 14. Right? In the initial compound OH, 1H reduced, and you are getting CH3 there. So CH3 mass is 15, right? And 1H is reduced from the original molecule. So total will be change of 14. Here how much change is there? It is also only 14. So how many OH groups has to be there? Phenolic OH, only one OH has to be there. That's why finally we are getting how many hydroxyl groups are there? Only one. That is why that undergoes methylation and it becomes OH2 OCH3. That means the gain of only 14 molar mass. Again listen to that if you want. The answer will be how many hydroxyl groups? 1. If the difference comes out to be, if that difference, suppose if it comes out to be 28, then for each we know what is the change? 14. If difference comes out in the final molar mass is 28, then we say there are 2 OH groups. Okay? Next question. That ester is given lithium aluminum hydride, A, B, C options are given. A give iodoform, B gives, both A and B gives, none will give iodoform. Think about this question. And then 15th, write down the product. These are the reactants given. Pause this video, you can try it. I am answering question number 14th. Okay. Now lithium aluminum hydride will reduces the ester group, so it will give what? It forms CH3, CH2, OH. Right side will give you the isopropyl alcohol. That's it. Now this your answer will be there. If you remember that iodoform is given by isopropyl alcohol. Why? It converts it into acetone. Here it is ethanol. Ethanol is converting to ethanol, and ethanol gives iodoform test. So that information you remember from the iodoform reaction. So both will give this test. 15th question is one ester, one carbonyl compound and strong base is given. So here what you can use firstly between these two alpha hydrogen of which is more acidic, of ketone or carbonyl is more acidic than ester. Why? Because with ester we know there is a OR group present, so it will give lone pairs also to this carbon. Its electron withdrawing tendency will be less, whereas ketone withdrawing tendency is more. So using just like aldol type reactions, alpha H removed, carbanion generated or nucleophile formed, okay, that will attack on the carbonyl group here. And which reaction takes place? Normally substitution. Carboxylic acid derivative with this nucleophile undergoes simply SN2TH reaction or substitution. So what is the product formed? It remains CH3, it forms C double bond O, this CH2 there, and then remaining groups as it is. Okay, so this is similar to, not exactly, it is similar to Claisen ester condensation, but in Claisen ester we take ester only, two molecules of ester undergoing reaction. Here ester with carbonyl generates nucleophile and this will attack on the ester group. Normal substitution reaction takes place. So explanation which is given Claisen ester is not exactly Claisen ester, but ठीक है, we can understand. Okay, thank you.